A bird's feathers enable it to fly, float, and regulate its body temperature. Unfortunately, feathers also absorb oil, taking away these crucial abilities. Images like these have come to represent the environmental toll of oil spills, like the Deepwater Horizon disaster that dumped nearly 5 million barrels into the Gulf of Mexico. Following that spill, responders contained surface oil using booms and tried to break the oil up using chemical dispersants. For the first time ever, dispersants were used deep in the ocean, near the leak's source, as well as on the surface. Steve Murawski led the government's efforts to determine the effects of the Gulf spill and the methods used to contain it.
The use of deep water dispersants was an experiment. You know, it's hard to say that, but it's exactly what it was. Obviously, this is a question of an environmental trade-off. Do you fight the oil at the surface and on the beach, or do you fight it in the deep sea?
That got Bob Lochhead and his colleagues at the University of Southern Mississippi thinking, what if there was a way to break the oil down and keep it from sticking, all while being environmentally friendly?
And where this came from was when we saw the oil spill, immediately we thought of how do laundry detergents work.
Laundry detergents contain chemical compounds that stop dirt from sticking to clothes.
And I thought, could we use this same technology in the oil to stop the oil from sticking to things like bird feathers?
Oil sticks to all kinds of organic materials, including feathers and hair. So the standard methods of protecting wildlife from a spill are to try to block the oil from reaching sensitive areas and clean the animals that get oiled. But what if chemistry can keep the oil from sticking in the first place? So Lochhead and his researchers went to the lab looking for a way to complement the strategy of using dispersants to break up the oil. Because of the urgent nature of the spill, the team needed answers quickly. So they used a specially designed robot that allowed them to try thousands of compositions daily.
You see, the problem you've got with these systems, you're looking for a composition that's like looking for a needle in a haystack. You may have to screen thousands and thousands of compositions before you find one that works. Well, the problem is we had only months to do this. The oil, you can't wait 20 years while the oil's moving around. The way we were able to do this is you've seen the robot, and that robot now can make about 10,000 compositions a day, whereas a normal formulator in the lab does about 10 a day.
The team started with chemical compounds widely used in detergents and identified other chemical contenders, but none really stuck to the oil. Then they tried soy lecithin, which is used in everything from candy to cough medicine. Experiments showed that the soy lecithin coats the oil droplets, preventing them from sticking to anything, but still allows microbes in, ensuring that the oil breaks down. In the lab, the research team prepares emulsions of oil and water. The team is also testing absorbent material that acts like a giant paper towel when pulled through a plume of oil, absorbing oil but not water. Now, the researchers are trying out the unique mixture in the lab. A feather dipped in oil and seawater in a tank. Dipped in untreated oil, the feather is like a sponge, soaking up the reddish oil. But in the tank with oil and the successful additives, the feather comes out nearly clean. Lochhead says the approach needs more development, but he's optimistic they'll be ready for the next big spill.
We're at proof of concept level. We've proved that, yes, this thing will work. What we need to do is now find the ideal mixture that works, to find how we put it together into a product, how that product will be stored, and make sure it's got 5-year shelf life, and how it will eventually be put, hopefully, on every rig and every tanker, just like a fire extinguisher.
Researchers hope they will have a prototype ready in a year and clear regulatory hurdles within another year. For the wildlife most threatened by oil spills, a viable product can't come too soon.